All right, perfect, great. Hi everyone, hello. Am I audible to all of you? Can everyone hear me? Just write a quick yes or no in the chat so that I know I'm audible to all of you. Anyone who's not able to hear me, anything like that? Perfect, great. All right. So we have quite a decent attendance right now. So I think we can quickly get started. As and when more people will join, they'll also start accommodating to the session. Okay. All right, perfect. So I hope everyone is excited for today's session. I am very excited for the first session for Java today that we are starting. Okay, and I believe a lot of you would have been waiting for the time as well that we actually start this course. So today is actually going to be the first class where we actually start programming in Java. Okay, and I will be taking your first set of like a few set of first classes for this particular course to help you become comfortable with the overall idea of what Java is, what are the few basics in Java that you need to know, right? And multiple other concepts related to that. Okay. A few things to kind of remember before we start the session is where I would like to kind of help. Chat is not enabled. 1 second. Now, are you able to write everything in the chat? Awesome. I was wondering why nobody is writing in the chat. Perfect. Thank you. All right. So what we'll do is today, the idea would be that we would try to keep the session a little bit hands-on, a little bit practical. Okay. But a lot of it would actually talk about, fundamentals of what Java is, what does Java really works on, right? What is the scope of this particular class and right? And what can you expect in the future classes? Okay. So are we all ready? Should I just share my screen and get started? Perfect, great. All right. Let me know when my screen is visible to all of you. All of you can see the screen, right? Awesome. Let me also get the participant list. Okay. So just remember that I'm very good with names. So by the end of 2-3 sessions, I will most probably remember all of your names and I would know who everyone is and what's your progress in the course. Okay, so be assured about that. A few things that I would like to kind of call out, a few general things that I would like to call out would be very crucial. So let me just point those out as well. A second to make sure my iPad is fully connected. First of all, be very active on Discord. Okay. There are a bunch of people who are not that active on Discord and they were kind of DMing me about, what's the schedule and when's the class going to happen. So every announcement is going to come on Discord. So make sure you're fully active on that. The second point is going to be kind of related to structural. Okay, I hope everyone had gone through the recording and basically installed either IntelliJ or I would say VS Code on their systems. I hope everyone has this kind of a view for them. I did share a bunch of recordings where you would be able to kind of get and set up this kind of a screen, which I have over here right now. So I'm assuming everyone has this screen. If you do not worry. This class is going to be very fundamentally basic, right? So even if you don't have it, you can just watch the screen and maybe after the session, you can watch the recordings, which I shared in the announcement section and install either IntelliJ or VS Code. Okay. In terms of popularity, feel free to use any ID you want. There is no restriction whatsoever on this course, right? But popularly, I would say IntelliJ is very, very famous. And apart from that, VS Code is also kind of gaining popularity. Eclipse is something which was also very popular for Java, but not so much anymore, right? People don't use Eclipse so popularly these days, right? But if you feel comfortable with Eclipse, feel free to do that, right? There's no rule whatsoever. There will be a very good amount of resources available online, which will help you to set up, I would say, Java in your systems and the IDE on your systems, right? I am using IntelliJ over here, but please don't feel constrained by the fact that you also need to use IntelliJ if I'm doing so. Okay, I have zoomed in. Is this much zoomed in good for everyone? Like, I hope this much is enough for you to kind of see everything which is happening on the screen. Perfect. Apart from that, for the basic sessions, just sit back on your seat and listen to what I'm saying, okay? Please don't feel the need to write when I'm speaking, okay? It kind of takes away your attention from what I'm speaking, what the video is, right? And then you have to parallelly write as well, okay? I'll try to give as elaborate notes as I can. And by the end of the session, I will upload those notes also so that you can watch those and, go through those notes later, okay? So if you're not someone who has this, gist for kind of writing continuously, feel free to just sit back. I'll be writing everything that we will be doing. Okay, so you just focus on your mind and listening to me. If there is a way where your interaction is required, I will let you know, that this is a problem solving class. Your interaction and your intervention will be required at those period of times. Just quickly, write yourself also and keep answering in the chat as well. Okay. I will be going through a bunch of content, right, where I will be kind of teaching you a lot of things. So first, let me go through the entire content, right? And then in case if you have any questions, right, we will take all those questions as well. Okay. And yeah, I think this much is enough so far to kind of help you get started. When we'll move forward, we'll kind of, get more comfortable with what is exactly going to happen in the course, what's the assignment structure, what's the test structure, everything will get comfortable. Okay. So if everyone is good, should we get started? I'll share back my screen again if everyone is good. Awesome, great. So let me pull up my screen back. I have the chat window as well. And I have the participants as well. Okay, perfect, great. Perfect. We are now good to go to get started on the very first session to talk about what is programming. So today's session is going to focus on introduction to programming. Okay, so before we get started, I just want to understand very quickly, just to understand what the audience is like for this course. How many of you are very comfortable with programming? That means you know what programming is, you know the basics of for loop, while loop, right? You know how to basically create variables, you know how to manipulate variables, right? You know what data type is, you know what comments is. How many of you know what exactly these concepts are? Perfect. Okay. And how many of you are completely beginners to programming? Like you don't know anything about programming, right? And this is the first time you're probably hearing the word as well, and you're not really comfortable with any of the concepts. Is there anyone who's like that as well? You can just write maybe me to kind of represent that, you're completely beginner and you probably do not know anything about programming whatsoever. Okay, so I see Akshay is completely beginner. Fine. Awesome, great. So I see like we have a good bunch of people who are kind of comfortable with programming, and there are a handful of students as well who are kind of beginners and not really know a lot about programming. Okay, so we'll keep those things in mind, and then we'll kind of, trek through this course to make sure nobody gets left behind. All right. Okay. So what we are going to today talk about is Java as a programming language. Okay. So we'll try to take some real life example to kind of see what exactly programming is, right? For example, I go to France, right? And I have to say hi to someone, right? Now, I can't be using my English language to do that, right? Because French people don't really understand English, right? And they're very apprehensive about using it. So what I would do is I would simply say maybe bonjour to them, right? To help them understand that I am saying hi, right? For example, in the same thing, it would happen in, the language Hindi also, English as well, right? German also, right? And so many other languages, Russian also, right? So the idea being that you're trying to say the same thing, which is, let's say you're trying to greet someone in a particular language, right? So your objective is same, what you're trying to achieve, but you are using different means of communication or different language in order to do so, right? When we talk about computers, when we talk about programming languages, it is pretty much the same thing. Okay. For example, if I have a computer and if I want to print something on the computer, right? If I have to use Java as a language to do that, the command is system.out.println hello, right? For example, if I want to use, let's say, cout, in order to say hello to someone, I would simply use cout hello in order to do that. For example, I have to say that in JavaScript. So I will say console.log hello and do the same thing. Okay. For example, I have to use C#. No, I'm not bragging. I just know these many languages. That's why I'm telling to all of you. So it will be console.writeLine hello. Okay. If I have to do in Ruby, I would do puts hello. If I have to do Python, I would do print hello. Okay. Now, the reason why I basically told you this was many people come up and say that, ma'am, should I learn C++ or should I learn Java? Okay. Or should I learn JavaScript or should I learn C#? Okay. The common answer to all of these questions is that it is just a mode of making communication with your computer, with your CPU, right? It's not really going to make a difference if you say the same thing in C++. The same thing can be told in Java also. The same thing can be told into JavaScript as well, right? So your computer understands all of these things. We'll talk about how computer understands all of these things, right? But know that it doesn't matter which language you usually use, right? A computer is capable of understanding all of these languages, right? Because in the end, what you're doing is you're simply saying hello, right? So it doesn't really matter. Do you use Java? Do you use C++, right? Or do you use any other, modes of communication in order to do that, right? The end objective is that you should be able to say hello, and that thought should get communicated to the computer, right? In this case, in this course, for those of you who would have enrolled in the JavaScript course, they will essentially be getting comfortable with this kind of a statement, right? But because all of you have enrolled in this course, you would be using this kind of a syntax in order to be able to say and communicate hello to the computer. Right? This is what in a nutshell is about how different languages are created. Now, there could be differences about speed. For example, C++ is considered faster than Java, right? So that is why competitive programmers prefer C++ while writing code, because it's quite faster compared to Java. Again, depends on the nitty-gritty details of how these languages are built and on top of what they are built. Okay. Similarly, we say that Python is more preferable for machine learning. Why? Because it's the syntax for Python is very verbose, and for machine learning algorithms, Python fits very nicely. Okay. Now, for example, Java is very useful when you are kind of eventually going to learn web development and use Spring Boot. Okay. Spring Boot is a very, very popular language and very scalable in future to make microservices and to make a good bunch of backend projects, right? So Spring Boot is a framework made on Java, right? So that's why you might prefer Java if you eventually want to use Spring Boot, right? I am personally a fan of Java. I have been using Java since my college and I'm quite comfortable with it. So I kind of go ahead with this language. But again, it doesn't make a difference what you work on, right? I used to work at Flipkart. I used to work specifically in Java over there. I used to do my internship in American Express. We used to heavily use Python, right? I used to work at Scalar Academy, Interview Bit. There, the entire code base was in Ruby on Rails, right? Now I work at Microsoft and we use C#, right? Never language as a barrier did stop me from making or working in a different company, right? I could have simply said, no, I come from a Java background. I can't in Microsoft just come and use C#. No, it doesn't, it never makes that difference, right? I used to work in JavaScript. I knew this was the syntax. I just went on the internet, learned the syntax for using C# is this, and that's it. The good thing, luckily, was that the syntax for Java and C# is actually quite similar, right? So I had to learn, or the learning curve was very low for me, right? But understand that language as a barrier should never stop you to do programming, and it doesn't make any difference in what language do you really use and in what language do you really do programming. I hope that makes sense to everyone. Anyone who has any doubts, any questions till now? Anything, like anything that you have in mind so far? Awesome. Just stay a little bit active on chat. Okay. That is the only thing that I kind of require from all of you. Okay. Rest, all is good and is fine, whatever you guys are doing. Okay. Perfect. All right. Now, what we will do is we'll talk a little bit about Java now as a language. I think we're now ready to kind of go into a little bit of detail, right? And then we kind of talk a little bit about computers and then how Java kind of fits in the entire picture. Okay. Right. So the next thing that we are going to talk about is Java specifically and move away from the world of all the languages which are present in the world. Okay. So Java, whenever we talk about, it is considered to be a multi-platform, object-oriented, network-centric language. Okay. Now you might be feeling that, these are a lot of words that we kind of introduced right now. Okay. For the time being, just kind of understand that this is what Java as a language is, right? It will become comfortable and you will become comfortable with all of these terms as and when we move forward. Okay. Understand, for those of you who would already know, that C was a language which was a functional language. That means whatever code you used to write in C, it used to be in the form of functions, right? But Java is a object-oriented language, okay? Everything is kind of communicated through objects, and you are able to write code in Java through objects, okay? That is what kind of the idea is, but we are going to go in details of this, okay? Then we talk about the use cases, right, of Java, where exactly Java is being used. First of all, understand that you go to any statistic right now in the world of web development and in the world of even data structures programming also, Java is currently the most popular language that we are using for specifically big organizations, right? Specifically for organizations, for big MNCs. Small startups are kind of small startups are kind of still going ahead with Node.js because it's kind of easy to ramp up your code and make a basic skeleton code in Node.js. That's why startups prefer Node.js or I would say Django kind of frameworks like that. But I would say big organizations which are building projects on microservices try to go into Java because it's easier to find a Java developer. And secondly, it's very scalable when you work with microservices. Okay. In terms of use cases, first of all, Java is very, very popularly used for making Android apps. Again, mobile apps. Okay. Along with that, not just that, it is also very useful for making enterprise software. Anyone who knows what is enterprise software? Anybody knows what are enterprises software? So very simple. Enterprises softwares are those softwares which are developed for a company's organization's internal use. Okay. For example, I am working in my company. For example, I work at Microsoft. Okay. And over here, I am basically building a HR portal. Okay. Which will be used internally by the HRs of my company. For example, that is a portal which is used to filter students which have been rejected, which is kind of used to filter students which are in the interview process. For example, it is used to start the onboarding process of students, to send those onboarding mails. So there is usually a one portal which is used by HRs, right? Or this is a very simple example. Even the product that I work at Microsoft is an enterprise product. Enterprise product is that it's not available for the consumers for the entire world, right? It is usually designed either for the organization's internal needs, or it is basically designed for maybe the people, who are vendors of Microsoft, right? Or who are third-party consumers of Microsoft, something like that, okay? So enterprise softwares are those software. It is any software, but the use case is specific to a particular enterprise for a particular organization. That is in a nutshell what enterprise softwares are, right? So Java is very popularly used to make enterprise softwares, right? It is also very popularly used for big data analysis. So you know Hadoop. How many of you have heard the name Hadoop? Hadoop, Apache. Hadoop is a tool which is built by Apache, which is used to do big data analysis and which is used to work on big data. Okay. So the moment you download Hadoop or the moment you download Apache Hadoop in your systems, a prerequisite is to have Java installed in your systems. Okay. So that is what the idea is, right? You don't have to go deep into big data and everything, but understand that Apache Hadoop is a tool. And the moment you download that tool, right, in your systems, Java is a prerequisite which is supposed to be there in your systems. Okay. So without that, Hadoop will run on your systems. Spark queries will not run in your systems. Okay. So that is again where Java finds a lot of use cases for big data analysis, right? Apart from that, I would say it is again used very popularly to use and build microservices project as well. Again, microservices is something, for example, you have your code base written in entire one repository, right? One entire code base, which was what was happening when I was working at InterviewBit, right? There were 30 developers and 30 developers used to contribute to a single repository, a single project, right? That is known as a monolithic architecture, okay? Mono means one, monolithic architecture. Microservice architecture, as the name suggests, is that you have one big project, you have distributed and divided that project into small different project and services. For example, you make an e-commerce platform. For the e-commerce platform, it's a huge project, right? So one project is the orders platform, right, where every order is coming. One platform is, let's say, the payments platform, where all the payment are happening. One platform or one project, which is kind of, again, the main project divided into small services. Another services could be where you have, let's say, you are kind of handling the cart functionality. One system is where you are basically happening or taking care of the business functionality, right? The vendors where they are able to upload the project, right? So when you take one big project, divided into small services, divided into small project, that is microservices. One service divided into microservices. Okay. This is microservices. Don't have to go too much detail into this. We will be kind of going ahead into detail into this later when we kind of move to web development, but it's always good to kind of know these terminologies. Okay. So that is what exactly the use case of Java as a language is, right? So I was saying multi-platform. Okay. Now the terminology will make sense. Java can be used to make Android applications also, mobile applications also, as well as it can be used to make web applications also. It is kind of then again used to, although preferably Java is used for microservices, but nonetheless, it can also be used to make monolithic projects as well, right? So since I would say Java as a particular project or Java as a particular language can be used to make different kind of projects, right? That is why we say that Java is very popular. It can be actually run into, or it can be actually used to make applications which are compatible for a lot of platforms. Does that make sense? I hope that makes sense to everyone, what exactly Java as a language is, right? And where exactly does it find its use case? Okay. Now, if everything is clear, right, what we'll do is we'll kind of move a little bit away, right, from what exactly Java is and talk a little bit about computers right now. Okay. Ma'am, please repeat third point. Third point is this point, big data analytics. Abe? So, like I said, so if you don't know about big data, then you might not be able to draw a lot of references into it, but a historical data, right? So big data is getting very popular these days. A lot of historical data is present and archival data is present with companies these days, and they ideally want to be able to use that historical data, right? For example, Instagram has so much historical data available about you, right? That is why you will see that if you talk something about 2 minutes with your friend, you immediately start getting recommendations based on that on your Instagram reels, right? I think everyone would have kind of encountered that use case. I was just, I think, talking to my friend about Fast and Furious X, the movie these days, like 4 days back, and I was only getting recommendations about that movie the entire day on my Instagram reels, right? So what happens is Instagram actually uses all that data which is available to you. That is, again, because it is such amount of big data present, they call it big data, and then they use that big data to draw insights about you and then eventually use those insights to make recommendations for you on Instagram. Okay, that's the flow, right? Now, to do all these, analytics and to draw all these recommendations, the tool that we use is Apache Hadoop to be able to draw analytics on the big data available. And when you download Apache Hadoop and when you set up Apache Hadoop, the prerequisite is to have Java in your systems. Okay, so Apache Hadoop actually runs on top of Java, right? So that is why I said that Java as a language finds its use case in big data analytics as well. Clear to everyone? Once again, I've repeated also in case anyone had any doubt, it would get clear now. Can I get a quick yes from everyone so that we can move ahead? Awesome. Now, let's move forward and go a little bit grassroots over right now. Okay, forget Java for like the next half an hour and let's just talk about computers. Okay, let's forget about, I would say, Java for at least the next 20-30 minutes. And let's just talk about computers, okay? Computers came into existence really early, right? I think the initial set of computers and systems, or PC, personal computer, right? Like you call it, right? It came into existence long back, and they were very big machines, right? If you would have kind of gone through your 7th, 8th class, computer science classes, you would have seen images of, I would say, a room which was filled of just CPU and computational powers to show how in early systems, right? And in early days, I would say the systems were quite huge, right? And the machines were quite huge, right? But now I would say personal systems have kind of compressed into very small sizes, and then laptop has taken over the world and iPad has kind of taken over the world, right? But when you talk about the definition of what exactly is a computer, right? The very simple definition of computer is that a computer is an electronic device that is used to perform computation. Okay, so if you kind of roll back to the early days, for the reason the computer was actually introduced was just to perform computations, right? People didn't really want to kind of use Netflix and saw movies on computers. There was projectors available for that, right? Nobody wanted to really kind of do big data analytics and AI and ML. Nothing of that sort was available. People just felt that they had to add 2 numbers. It was a very human intensive task and prone to errors, because if you have to add big numbers, there is common way of human making errors. So they just wanted something which was kind of able to, do those computations very, very quickly, right? So a computer was nothing but an electronic device which was capable of performing computations, right? Now, we know now these days that a computer now has a monitor, it has a keyboard, it has a mouse, right? It also has, I would say, a memory, right? Which is able to store information. Like our brain is able to store information, computer also has a memory which is able to store information, right? But we're not going to talk about keyboards and mouse and everything today, right? We're going to talk about processors. And I hope since all your schooling, you would have heard this terminology a lot, that processors or the CPU is considered as the heart of the computer. Yes, this is a very common thing we hear, that computers are something which does the thinking for us, right? Computer processors are something which does all the thinking, right? But the question is, computers do all the thinking, but how do computers does this thinking, right? How is computer actually able to understand a text, right? As image, as videos, anything else, right? We as humans have gone through so much schooling, right? We've gone through our UKG, LKG, first standard, 12th standard, and then we've done engineering or any sort of course, right? Then we know what is an image, what is a text, what is a video. So do we go ahead and train computers like these, right? Or how exactly is processor able to do all of this for us, right? That is what we are kind of going to talk about today in this session, and then link that story eventually to Java. Okay. Now understand this way, that computer, I told you, is an electronic device. Okay. So let's say fan is also an electronic device. Agreed? Fan is also an electronic device. Does fan do any thinking? Is fan able to do computations for you, right? Or let's say, for example, you have your washing machine or your geyser. Is it able to do any thinking for you? No, right? It's not capable to do that, because a fan is only able to understand that a fan is turned off or a fan is turned on, correct? Fan cannot do anything for you except for the fact that fan only knows that is it turned on or is it turned off, okay? Believe it or not, it is the same thing with computers as well, okay? Computers only understand electronic signals or binary signals, or binary means 2 over here, okay? So computers also as a device only understand electronic signals or binary signals. Computers are not able to understand anything apart from that. Either a computer is turned on or a computer is turned on off. Either there is energy or power reaching to the computer, or is it turned off and it is not reaching the computer. Okay. For example, let's say your system basically uses a 5-volt electronic signal right over here in order to turn on the computer. Okay. So what the computer says is, if the power is coming to the system, it means 1. If the power is not coming to the system, if it is, let's say, 0 volt, it is 0. That is what the computers do, right? For example, if I tell you how computers are really understanding everything, the graph is sort of like this. Either it is 0 or there is 5. Computer does not understand anything else, right? It would either know 0 or it would either know 1. Okay, computers are not capable to understand a language. Computers are not able to or capable enough to understand text, images, videos, JSONs file, Parquet files, XML files, CSV files. Computers are not capable to do anything like that. Okay, they are just able to understand 2 things, 0 or 1. Okay, that is binary signals. Okay, and what they actually do is, now on top of that, they kind of club 8 bits together. So this is bits, 0 and 1, those are known as bits, right? So what they do is they kind of club these 8 bits together. Any example I'm just giving to you, right? 8 bits together are known as bytes, right? So they kind of understand and club 8 bits together, make it a byte, and then interpret text, numericals or symbols. Okay, so if you write this, or maybe if you write this, or maybe if you write this, computers don't understand. Okay, what computers actually do internally is They say that for them, this is equal to this. Any kind of 1, 2, 3, 4, 5, 6, 7, 8 mapping. For them, this is this. Okay. For them, this maybe this. I don't know the exact configuration, but for them, what they do is they kind of club 8 bits together. Now you can understand at every, if there are 8 bits possible, 1, 2, 3, 4, 5, 6, 7, 8, at every position, you have 2 options, 0 or 1. So there are a total possibility of 2 to the power 8 combinations of digits and text possible, correct? If at every position, I'm saying computer understand 8 bits, at every position, you can either put a 0 or a 1. There is a total of 2 to the power 8 different kinds of characters or symbols that the computer can understand. So what it will do is it will make a unique, I would say, bit or unique 8 bits for each and every character. And that is how it kind of does the interpretation for you, right? For example, when you write number 1, no, right? Or when, let's say you write number 0, for computer, it is this 3, 4, 5, 6, 7, 8, all zeros. When you write this for computers, it is actually this. When you write 2 internally for computers, it is this. When you write 3 for computers, internally, it is this. Does that make sense what I'm talking about? When you write this, so this is what humans write. But this is what computers understand. How this conversion happens from what you write to what computers understand is still to be discussed. But understand that computers don't really know what 2, 3, 4 exactly is. They don't really know what hash is. They don't really know what @ is. They don't really know what AND is, right? They actually do this conversion, right? And on top of this, they do this. Okay. 2 to the power 8 Venkat is actually enough to be able to consider basic characters. Okay. And even if it goes on top of that, we have, like I will talk about certain mechanisms available to be able to deal with all of that. Okay. So this way of computers actually doing this, right, is known as 8-bit computing. You remember, like now you will understand sometimes in your school or maybe when you were in first year also, sometimes people used to ask, do you have a 32-bit machine or do you have a 64-bit machine? Whenever you go to the internet to download some software also now, sometimes it asks you, do you have a 32-bit machine or do you have a 64-bit machine? Have you ever come across that situation? Where it sometimes asks questions like these? That do you have this kind of a configuration or this? And based on that, you download. Okay, exactly. This is the logic behind that. The thing is, I think who asked the question? I think Venkat asked the very right question, right? What if number of characters go above 2 to the power 8, right? There should be mechanisms to handle that, right? And with so much languages, not these are all digits. Then there is English language characters. Then there are Chinese language characters, right? Then there are German characters, right? How a computer will definitely, or a world will definitely have more than 2 to the power 8 characters, right? How will you handle that situation? To handle that situation, nowadays, you will see machine comes up with 64-bit computation. To be honest, now 32-bit machines have actually stopped coming in the market. Even if you will buy a new laptop, 64-bit machines are coming in the market. And hence the answer to your question, that because the number of characters and the way these values can actually increase, we have actually left the 8-bit computation machines anymore. And we have come up with 64-bit machines. And now you can understand 2 to the power 64, right? This is capable enough to kind of take up all that you have available in the world. Does that make sense? Awesome. Now you would ask, ma'am, okay, you talked about computers. You talked about how, how exactly this is all understood by computers, what exactly computers understand. But how come this link is happening between Java and how this link is completely having between, I would say, computers, right? How they are actually interconnected. Ma'am, aren't those more related to the architecture rather than the memory allocation of those variables? Yes, you are right. Somewhat it is. Don't worry about that. I will come to that. Okay, I will talk about chips, memory, Intel configurations, everything. We'll talk about that as well. Okay, don't worry. We are going to utilize the first two classes to kind of go more detail into these concepts and kind of handle these situations. All right. So that we actually know what a computer is, and then on top of that, we learn what Java is, right? Okay. So like I was saying, computers understands zeros and ones and everything, right? But you write typical English, right? Or if not complete English, what you write Java is very close to what you understand. But machines understand something else, right? So there should be a mediator in between that is supposed to be handling everything for us, right? That is where two concepts, which is assembler and compiler, comes into the picture. Okay, so we'll first talk about assembly language, which kind of bridges the gap between what you write and what computers actually understand. Okay, for example, you want to basically tell the computer to add two numbers, 1 plus 2. Okay, now which are obviously being represented by binary numbers, right? I told you 2 is represented like this, and 1 is represented like this, 1, 2, 3, 4, 5, 6, 7, 8. Okay, now you want to add these two numbers. How are you going to tell the computer to do this task, which is 1 plus 2, right? How are you going to tell the computer, right? What we are going to do is, in this case, we are going to use assembly language, okay, which is going to get our code executed. Okay, now assembly language is the most elementary form of software languages. Okay, now what we do is, when you actually do, or when you actually write in your computer 1 plus 2, right, we give this command to the computer, right? And what happens is, assembly language actually does this to your code, right? It basically says store 1 at memory location 1, okay, memory location A, store 2 at memory location B, right? Add contents of location A and B, okay, and then store the result. This is what you do, but this is what assembly language does to your code. Okay, it will basically take care of all of these things, right? But you will say that, you know, ma'am, I wrote this code. Even this conversion, how is this happening? How does, when I do 1 plus 2, right, it is actually getting converted into this, right? Or this kind of like a format, right? So back in 1950s, when computers were huge and actually consumed a great deal of power, right, what happened was, you would convert your assembly code into machine code. Okay, so 3 terms I introduced. The code we are writing, which is Java, is known as source code. Okay, the code which your machine, right, or what your PCs understand, is known as machine code. Okay, kind of understand these terms, right? So what would happen is, earlier, and the code which is in between, which is generated by assembly language, is known as assembly code. Okay, so earlier in 1950s, to convert this code to this code, which is the machine code, which is the 0-1 code, right? To convert corresponding machine code to ones and twos, there used to be mapping sheets. Okay, and later what we used to do was, this code was actually punched into machine cards, okay, and then actually fed to the computer. So there was someone kind of who was using these mapping sheets, right? And then they were kind of punching those sheets. For example, if someone is at A location is 1 is present, then they used to punch in those machine cards, those binary values, then feed it to the computer. The computer will read those codes and then execute the program. Okay, but for our rescue nowadays, what we have is a assembler present. Okay, to go from assembly code to machine code, we have assemblers present to our help. Okay, so with the advancement in technologies and a lot of input output devices that are being invented, what you could do is you could directly type your program into the PC, okay, using assembler, okay, and it will correspondingly convert your it into machine code, right, and then feed it to the processor. Okay, for example, coming back to the example of addition of 1 and 2, the assembler, what it will do is store 1, store 2, or sorry, store 1, location A, store 2, location B, okay, 3, add location A, location B, 4, store results. This is your assembly code. The assembler takes that code, okay, and then converts it into 100000100, something like that. And then these, for example, your system is using an Intel chips. You know, right? These days, earlier Apple and their laptop is known as MacBook. They used to use Intel chips, which is again a processor, right? Intel chip processor. Now, what are they using for a processor in their laptops? Anyone knows? M1 chips. Very good. So it's just always good to stay updated in the market, right? Earlier, Apple was using Intel chip processors, which were, again, like I said, the thinking brain of the computers, but now they're actually using M1 chips, right? So now what happens is, again, but still in, I would say, Windows and like still, I would say, ThinkPads and Lenovo systems and Dell system, you still have Intel chips present only, right? So again, what happens is the assembler actually converts your code again into 1, 0s and this binary code or this machine code, and which your processor is kind of able to understand. Okay. That is how this process is happening, of how your assembler code is getting converted into the machine code. But there is still something else present as well, right? Assembler is not alone involved in this process of when I write the code in Java, okay? It also requires compiler, okay? Again, a new term that I'm introducing, compiler over here, okay? So a compiler is actually required to compile the long code that I have written in my language, which could be Java, C++, or C#, any language, into small chunks of code, okay? What they're doing is, with the advancement of, software languages, I would say actually now the entire assembly code that you actually wrote could actually be just shrinked into just one line, right? So this is not what is actually happening these days to create your assembly code. Assembly code doesn't look like this these days, okay? Assembly code has kind of become very shorter and compressed these days. And when you when you say actually do 1 + 2, this is just what your assembly code is these days, okay? This is a very old example. This doesn't happen anymore. Your assembly code has actually been kind of compiled into very, very small, okay? And how could it be done? Using the concept of compiler, okay? So what compiler does it actually converts your code into assembly code. Your code as in the source code, the language code, Java, C++, anything that you have. Right? Now this assembler then after that converts it into corresponding machine code. So the entire picture is, when you write, for example, I'm using Python, I do print 1 + 2, you have your compiler first fit into place, which does this. First, again, I'm writing just to, I'll not be going too deep like this into all the classes, right? But since it's beginner classes, so you should know how everything is working and you should have a good set of notes. Location A, store 2, let's say location B, right? 3. This is an old example. Like I said earlier, now it is not that long. Add location A, location B. Now, after that, let's say you have to print this. So you know, right, when you are printing something on the screen, your input output devices are kind of active, right? You have to print something on the screen. So your monitor is now involved, and probably if something is popping up on the screen, you have to click on something. Your, I would say, a mouse is also involved. So once you do this, you store the result somewhere again in your computer memory, and then you make an operating system call to, let's say, the monitor to be able to print it, right? And once this is done, then you have your assembler put into place, which is again kind of going to convert all of this, what you wrote, into, I would say, zeros and ones. And then this is your probably Intel chip to be able to execute it. So this is behind the scene, what is actually happening when you write your simple code. Okay, now understand again, this is also a little bit earlier days. These days, what happens is compilers actually come bundled already with assemblers, right? That can directly convert your high level code to directly this code, right? So it's like compiler and assemblers are bundled together these days, right? So you don't have to go through this three-step process. It's actually faster also that way. Both are bundled together and your code directly gets converted. Does that make sense to everyone? Right? For example, now suppose Windows operating system actually runs on Intel processor, okay, which is actually a combination of operating system plus the processor. Okay, now that is basically called platform, right? So the most common platform in the world is Windows, right? And Intel is basically called the Wintel platform, if any of you would have heard the terminologies. Okay, other popular platforms are AMD and Linux, PowerPC, and Mac OS. Okay, so these is kind of, I would say, everything is now bundled together, which is again optimized, faster, and that kind of helps for the advancement of technologies as well. Make sense to everyone? Because now I'll start to connect everything with Java, and we'll come back to the story of Java over here. Any questions, any doubt? Everyone is good so far? Like anyone is anyone feel that we're going too fast, or anyone feels we're going too slow? Anyone like that? This is the first session, so it'll get a little bit time for us to get comfortable with each other, but I'll try to accommodate you the best of my abilities. Everyone is clear? Everyone is able to understand as well? All right, Venkat, I'll write nicely. Perfect. All right, now what we'll move to is the next part, right? Now I told you, right, it's kind of we have operating systems, right, kind of connected to, I would say, the processors, right? Milind says our operating system are specific. Yes, so there are situations, right? Again, earlier we were used to having specific like these, right? But nowadays it's kind of like everything is coupled. For example, Mac OS as an operating system was kind of using I would say Intel, right? So they were kind of clubbed together, but it's not like, but now the same Mac OS operating system is kind of being clubbed to, M1 chips, ARM M1 chips as well, right? So that's not the case anymore. Earlier, yes, it used to happen that we used to club together again to kind of increase efficiency, but kind of again, operating systems are kind of going away from that functionalities anyway. Okay. All right. Like I was saying that, I talked about how processors are kind of linked with operating systems, right? But don't you think, let's say, in this entire story that I just talked about of having Intel chips in the end, the question that could come to mind is, if I change the processor, will the assembly instruction also change, right? That could be a valid question, right? For example, I don't use an Intel chip here anymore, right? For example, I use another chip. For example, I use an AMD chip over here, right? Or I use a PowerPC chip over here, right? How will, or does the assembler code actually change, or the assembly instructions also change as well, right? The answer is yes. Okay. It may happen that you may do the addition operation in a AMD chip is like this, addition, right? But it may happen, for example, for a PowerPC chip, you may do it like add, right? Now, the thing is that now with a change in operating systems, we are saying that because assembly instructions can be different, OS operating system levels call and nature will also change, correct? As a developer, I do not want my software program to work on just one system, right? I would want my program to run on all the systems to maximize my revenue, right? Developers these days don't just make an application which is just compatible with Windows, right? Or they just don't make an I would say application which is just compatible for, let's say, Ubuntu systems, right? Or they're not just making it just to compatible with Mac systems. You would want your software programs to work on all the platforms to maximize your revenue, right? So does that mean because all of them have a different assembler, they understand different assemblers, would I also have to buy several, I would say different compilers that will convert my command into the native machine code, right? That is also a scenario. For example, I would say same statement, printf 1 plus 2, right? Now, let's say in the very end, I have 3 different processors, Intel, AMD, and PowerPC, right? What will happen is, because I said the assembly instruction could be different, what I would also do is, what I will also have to do is introduce 3 different compilers, okay? For this compiler, I would say, let's say if it is again the Intel compiler, then I think it's same. Assembler, converting into 1011, and then you have the Intel chip at the very end, right? But for example, at the very end over here, I have the AMD chip. And I just told you different processors, different operating systems kind of don't understand the same assembler, right? So what will happen is here, for example, an AMD chip understands this way: addition, location A, location B, and then OS calls, okay? So which will be again fed to the assemblers and which will again convert the code. For example, the same thing I am doing with PowerPC, right? Where let's say PowerPC kind of understands this assembly code, which is math, add, location A, location B, OS calls, then it is fed to the assembler, and then it happens, right? But now, don't you think in these situations, we will have to buy 3 different compilers because my 3 different processors understand this different level of, I would say, assembly codes or assembly instructions over here, correct? But however, both, however, are on the same architecture. So does that not help? No. Architecture does not really kind of help to understand what exactly your processor is trying to understand in terms of assembly instructions. They are kind of a little different. Architecture kind of understands how those instructions will be processed, okay? But the way it interprets the instruction could be different for different processors, okay? Does that problem statement make sense to everyone, right? That because different processors understand different level or different types of assembly instructions, you will have to have now different compilers as well so that they could convert into the relevant assembly instruction. Does that make sense to everyone? Everyone. I see a reply from a lot of A's and not a lot of T's and a lot of S's. Okay, perfect. Understood. So we are clear with the problem statement, right? The thing is, assemblers, and not assemblers exactly, but compilers actually are very expensive, okay? And there is a chance that even if, for example, you buy a separate compiler to fit in for the separate assembler, there could be compatibility issues, right? And the role of assembler, I will repeat over here, is again to convert this assembly code to the machine. Right? That is what the entire purpose of assemblers is, right? But like I said, even if you buy a separate compiler, which is anyway very expensive, right? It is not, I would say, exactly the way that they will fit like a glove, right? It could happen that they're not very compatible with each other, right? So buying and installing a separate compiler for a different operating system and then a different processor is not feasible at all. Okay, so what we need is something of a alternative solution over here, right? And trust me, languages like C++ are not platform independent. Okay, I told you what exactly is a platform. A platform is something where you have the operating system plus the processor, right? It makes up the entire picture of platform, right? But understand, languages like C++, they are called as platform dependent. Have you ever heard this terminology? That languages like C, C++, they are considered platform dependent, right? Whereas Java as a language is considered platform independent, right? That is what exactly kind of the way language Java steps in, finding a lot of applications, okay? If a particular code of C++ compiles on a operating system Linux, it will not compile the same way in what it is actually happening. If you take the same machine code, if you take the same assembly code of C++ and try to run it in actually, I would say, another processor or another operating system, trust me, it won't work that way. But cut to Java as a language over here, that Java is actually compatible across multiple platforms. Hence, Java is known as a platform independent language over here. Okay. So now, how does Java actually does that? Okay, steps in the terms JVM, JRE, JDK. Okay, I hope like is there anyone who kind of knows what these terminologies are? But I hope if anyone has heard the word Java, they would have been flooded with these terminologies. Java, JDK, JVM, JRE, है ना? And it's very common to get confused with all of these as well. That what exactly is JDK, what exactly is JRE, what exactly is JVM, and you know how all of it kind of stitched together. Is JDK a part of JRE or is JVM a part of JDK? Very, very common to get confused. Okay, but today we'll try to make sure that we let go of that confusion forever. Okay, so what happens is we'll first talk about JVM, right? It stands for Java Virtual Machine. Okay, now by using Java Virtual Machine, this problem of how you need different compilers for different assemblers for different processor is how it gets solved. Okay, by using JVM, this problem can actually be solved. Okay, but how it actually works on different processors and then different operating systems, right? Let's understand that process step by step. Okay, so what happens is you have your JVM, right? It stands for Java Virtual Machine, which is an environment on which your Java code actually runs. Do you know the environment on which, or a popular environment on which JavaScript code works these days? And people who have been in a lot of courses by AlgoCamp would know already. Node.js, right? Node.js actually is that runtime environment which actually helps to run your code, your JavaScript code. Earlier, internally, Node.js uses the V8 engine, right? Which was used to be present in just browsers. So only browsers could understand JavaScript code. But we took that V8 engine out of browsers. We actually made it compatible with our local machine, and hence the birth of Node.js came in. And that is how JavaScript code actually runs in your systems as well, local systems as well. Okay. Same, cut to the story of Java as well, right? That, Java actually runs on a runtime environment, which is JVM over here. Okay. So what happens is, first we'll go step by step. Okay. Yes, V8 is specifically for Chrome. Different browsers have different engines on which JavaScript code actually runs. Okay. Now, The step one is the code to display, let's say, the addition of two numbers is basically created, and the extension of the Java file is created. Do you know the extension of a JavaScript file? What exactly is the extension of a .js? Do you know the extension of a Python file? Py, right? Do you know the extension of a C# file? .cs. Okay. All right. I was just asking that. C# is not that popular, so not a lot of people actually knows about how it works. But anyways, okay. So in the same case, when you actually write this code to print something on the screen, it is system.out.println 1 + 2. Right? Now, this is the code which is used to display the addition of two numbers, 1 + 2, and it is actually saved as a .java file. Okay, the extension of Java code, Java program is a .java file. Okay, now using the Java compiler, the code is actually converted into an intermediate code which is known as a bytecode. Okay, this is your .java file in which you have written the code. This .java file is actually used and fed to the compiler. Okay, and using the Java compiler, the code is actually converted into bytecode. Okay, and the output of this particular code is a .class file. Let me show you that as well. Over here, if I go to the AlgoCam Java DSA folder, do you see over here that let's say here I created two files, hello world and main. Okay, these are actually the extensions here are .class. I hope everyone can see that over here, that the extension is .class over here. Correct? Everyone can see that, right? Paras, don't worry about that. The process of what Java is, Java C, how it is compiled, how do you run your code into a local machine, all of that will be covered in tomorrow next class. Okay, we'll talk about how the process of conversion, all of that works. Don't worry. And I think Millen's question is answered by Aditya itself. Okay, sandboxing is a feature of, is a very important feature, in fact, of a Java programming language, and I would say in development environment as well. Okay, where I would say, so you know what sandbox is? Sandbox is actually a program area and the set of rules that the programmers need to use while creating Java code. Okay, that is in Java, in the world it's known as applet. Okay, that is actually sent as a part of a web page. Okay, that is what exactly the idea is. But the cut short answer to that is yes. The long short answer to that is yes, it does work in a sandboxing environment. It kind of converts those rules and the way you have to follow into an applet, and then it sends to the web page. Okay, others don't bother about that. This is just very implicit and something extra that you know that will come in later as well. Okay, all right, coming back to the story where we left off. Okay, so we have the .java file, which is the first step. You write your code, it gets saved into a .java file. Okay, second thing, using the Java compiler, the code is actually converted into an intermediate code called as the bytecode. Okay, that bytecode, the output of a bytecode is actually a .class file. Okay, now this code that I just told you about, the bytecode, it is not understood by any platform. Okay, only a virtual platform called JVM. Okay, only JVM is something that can actually understand this particular bytecode. No platform is currently so far in the steps capable to understand this. Okay, now this virtual machine which I am talking about, JVM, is actually always residing in your computer RAM. RAM, I hope everyone knows, random access memory, the active volatile memory of your system, right? this JVM is actually existing in the RAM of your operating system. And when this bytecode is actually fed to the virtual machine, okay, or to the JVM over here, it then identifies the platform it is actually working on and then converts the platform into the native machine code. Okay, so here JVM is something which is doing the magic for us. Okay, it takes in the bytecode. Okay, that bytecode it takes, again, it's not by default runnable in any platform. It takes the bytecode, right? It kind of understands, then the JVM understands the operating system, then it understands the bytecode, and it makes sure that it converts that bytecode into the relevant native machine code based on the processor and the operating system. Okay, so you fed your bytecode to the virtual machine, it identifies the platform it is working on, and then converts the bytecode into the native machine. Okay, so while working on your PC or whenever you are browsing the web, right, whenever like you see, always be assured that JVM is usually loaded into your RAM, which is helping you to kind of run the code. Okay, but what makes actually Java lucrative is that code that is once compiled can not only run on all PC platforms, but also on mobile or electronic gadgets supporting Java. Okay, that's the power, or that's where bytecode actually steps in. This is not the case with C++. Okay, C++ has an entirely different mechanism for compiling your code, right? And it is very specific to the operating system and processors, right? Here, the bytecode is actually platform independent. You take that bytecode, you feed it to the JVM of any machine. Like I said, bytecode is something, and for example, your AMD chip processor machine also has a JVM. Your, let's say, Power PC processor also has a JVM in it. And your, for example, Intel machine also has a JVM in it, right? Now, it doesn't matter what the bytecode is. Bytecode also becomes relevantly over here, I would say, platform independent. As long as JVM is there in your operating system, bytecode will be converted into the relevant processing power of the machine which it is capable of. Okay, that is how the entire kind of process works over here. All right, let me see if I can just kind of fetch in maybe like example. So Java, understand that, okay, someone asked that dot class is not in the format of, I would say, the Java source code. Okay, it's completely different. Let me see if I can kind of fetch you an example also. Let's say, over here to kind of show you. Mahmood says that is JVM different from different platforms? No, JVM is same, right? That is why we just, every JVM is designed for different operating system, and bytecode is able to run on different system, right? So understand, understand it this way. JVM is going to be different for not every system, because JVM is machine plus operating system, which is different for every system that you have. Okay, that is why I would say when we talk about JVM is dependent on system because JVM is coded on C language. Does that make sense? JVM is going to be specific on the machine. When you will download Java also now, and in sense, I will talk about JDK, you will see, or you would have faced that situation, right? When you were installing Java in your systems, right? It would ask you to install JDK, which is having JVM, and JVM is it will show you different options, right? Whether do you want to download it for Windows, do you want to download it for Mac, or do you want to download it for this, right? So understand JVM is designed for different operating system, but the bytecode that you have, you fed it to JVM and JVM will take care of it. Okay, so the idea is to just to kind of clarify again, JVM is platform dependent. It is actually written in C language. If you ever Like, do you know systems engineer are kind of people who kind of work on the infra level things. They talk about this, right? JVM, the way you write it, it's actually platform dependent. It is written platform dependent because it is written in C language. Okay. So when a program is actually run, okay, that is how the entire idea works for that. But the bytecode that you have, that is completely independent of the language or independent of the platform that you work on. Make sense a little bit? Don't worry, we'll go more deep into these. We'll talk about the execution engines and everything related to that. But for a high level overview, this is kind of, good for you to understand that. Okay. Let me kind of go a little bit more deeper into it and all of it will make sense after that. Okay. So like I said, how does, to kind of come back to the question of how Java actually becomes platform independent, like the C compiler, the Java compiler does not actually produce native executable code for a particular machine. Okay. Java produces a unique format, which is called bytecode. Okay. It executes according to the rules that is laid out on the particular virtual machine specification. Okay. That is how Java becomes platform independent. Okay. Bytecode is understandable to any JVM installed on any operating system, right? In short, the Java source code can run on all operating systems. Okay. That means, where's my pencil? This is your operating system, let's say for Mac. This is your Windows operating system. Okay. For example, the JVM over here will be different. The JVM over here will be different for a Windows operating system, but the bytecode that will be written, it will be in a single unique format, and you fed it to any JVM. That JVM will kind of take care of the fact that it is converted into that native machine executable code. Clear to everyone? To answer your question, Paras is saying, is the bytecode and the binary file same? To answer that question, understand it that Java bytecode is a special kind of binary code. Okay. When you use the term binary code to mean machine instructions for a real processor architecture, right? Then it is different. Java bytecode is not binary code in that sense. It is a binary code, but it is a little processor specific kind of, you can say, so that the JVM can work accordingly on that. So bytecode is in a binary format only, that kind of consists of references, numeric codes and everything, but it's a kind of a special kind of a binary code. Clear to everyone? And this is how everything connects to the fact that a Java is known as a platform independent language. Any questions, any doubts to anyone? So Java doesn't really go into that binary code kind of a format. Okay, so it has evolved to kind of started using bytecode. JVM does not have an operating system of its own. JVM is kind of installed inside an operating system. It just provides a virtual machine. I would say again, a virtual machine is nothing but a virtual environment over which your code is actually running. Okay, so if we go deep into the terminology of what is a JVM and how does like everything work related to it, right? It's a machine. JVM is an engine that provides a runtime environment to drive the Java code or application. It converts bytecode into the machine language. JVM is a part of JRE. Okay, so in other programming languages, what happens is the compiler produces the machine code for a particular system. However, the Java compilers produces code for a virtual machine. They don't produces code. The Java compiler do not produces code for a specific machine. They produce code for a JVM, which is known as bytecode. Exactly. So if you want to make it cross-functional, bytecode is actually what you share. Again, this dot class file is actually what is able to run in all the platforms. Okay. Now I'm talking about the three big elephants that you will kind of come across very frequently. Okay. And I'm kind of writing some theoretical points also over here to help you understand this. Okay. JVM is an abstract machine. It's not a real machine. It's an abstract concept that enables your computer for you to run a Java program. Okay. Like I said, here the process goes like you have a Java program. You have a Java compiler. You have a Java bytecode. You have JVM, which is going to convert that specific bytecode into the specific machine and processor related machine code. Then it is going to run, the machine code is going to run on the CPU, and you will have your output generated. So Java is a platform independent language. It's because when you actually write your Java code, it's ultimately written for JVM, but not written for a machine, right? This Java code is specifically made for a JVM, okay? And since JVM executes the bytecode, which is platform independent, hence Java becomes platform independent, okay? So if you want to kind of go deep into and learn about what exactly is the JVM architecture, okay? So what happens is in JVM architecture, you kind of have class loaders, you have stack area, PC registered, right? Native method libraries, runtime areas, right? You also have execution engine. If you want to kind of read and go about that in detail as well, do you want me to share some articles also? So that in your own time, you can read about it if you want. I usually save some articles which I like to kind of, which I feel are good and which are kind of very, you know, user specific and kind of beginner friendly also. So let me share that. I really like this article. So feel free to refer this. It kind of talks about what is JVM, internally what is present in JVM, what are linkers, loaders, although we will learn linker loaders, which they are very important, but they're all present. PC registered. PC registers, I think they also come in computer networks, I believe. Which stores the address of an instruction. There's a stack area, right? There's a heap area, all of that, garbage collector, all of that is kind of explained in this article. Feel free to refer that. Okay. As a scope for this course, it's a little out of scope because it's not really kind of required as such. Correct. Yes. Computer organization and architecture is a concept which is there in, I think it's in second semester or third semester, which is comes and which is kind of very popularly used. Okay. So this is about all about JVM. Then we talk about JRE. Okay. So JRE is what it stands for. Java runtime environment. Okay. It is a software package. What is it? It is a software package that basically provides class libraries. Okay. JRE has JVM installed in it. Okay. And other components also. To actually run Java applications. Okay, so sort of you can say JRE is a superset of JVM. So JVM plus class libraries over here. Okay, so what happens is if you need to run Java programs, right, then but not develop them, JRE is what you require. Okay, let's say you just have a Java program and you want to run it. You do not want to develop any applications on top of it. JRE is what you will need. Okay, now JRE is again a runtime environment which has the JVM inside it, right? And along with that, you also have class libraries present in it. Anyone knows the concept of libraries? If you know about Node.js and packages, NPM packages and all, you would know a little bit about what exactly is the concept behind that. Okay, so it's like you want to do some mathematical operations, right? So there is already a person who has kind of written a set of functions, available code for you, which you can directly use. And later, when we move in the journey of Java, for example, you have to use arrays, right, in order to be able to do a lot of operations. So that is some set of code, some set of compiled code, which is already written, which you just import in your application or in your, I would say, code, and just like that, everything runs. Let me show you. I think in IntelliJ, I don't have that, but I would probably have class libraries in, I would say, Eclipse, because I was using Eclipse quite some time back, and that might have it. Let me check. So if you will see, let me just find probably something advanced so that you can, for example, this is the code from Cousrse. Doesn't have a library installed in it. Have I not used libraries anywhere? See, do you see this import java.util.linklist? Do you see java.util.stack? So stack is a data structure which is used to store your code. Now there are two ways to actually kind of use stack as a data structure. Either you create a stack of your own, right? Go ahead, create an entire stack of your own, or use someone already written stack, right? So this is, you can see this is a package. Package consists of a lot of libraries, class libraries inside of it. Why do I say class libraries? Because all of it is compiled in a class. We will talk about class, don't worry. It has all the functions available in it. How do you create a stack? How do you push elements to the stack? It explains very nicely also that this parameter is an item. Item is the value that you need to insert in the stack. You have the pop functions also available to remove. It explains the objective. Okay. So this is how it kind of works over here, right? For example, you have linked list. Okay. Now there are two ways to use linked list. Okay. First is either you use the already existing linked list. For example, this is the already existing linked list, right? Where you have everything available, or you create a linked list of your own, right? This is where I myself has created a linked list of my own. Okay. So there are again both ways to kind of do that over here. Okay. So what JRE, again coming back to JRE has a JVM in it, and along with that, it also has all of these class libraries present in it as well, which you can just directly import. This, the instruction is very simple, right? You just write import java.util.linklist, and you are able to kind of do that. Okay, Milind, okay, so over here, Milind, what is NPM stands for? Node Package Manager, right? So it's very, I would say, specific to Node, right? Or I would say JavaScript packages, right? Do you know a package manager? Package manager is nothing but these libraries and these packages only which are maintained, right? So for Node.js, the manager is going to be NPM, which is Node Package Manager. Do you know the package or manager for Python? Very good. Pip, right? Python packages are kind of maintained like that. Okay. So there is no name as such. I think that's what Vinayak says. To create a package, it is also able to do that. You can just create a name for the package and put the package over here. So don't you think over here, what I did was, this is a linked list client, a linked list class that I created inside which all the functions are present, right? Right. This is nothing but a package only because it is present inside module 1. And here this linked list client class now is actually using this linked list class only, which I created. That's why I am doing linked list class L is equal to new linked list class. If I hover over it and go to its implementation, right? See, it will take me here only. But if I go to this part over here and hover over here and take it to the implementation, it will take. So this is nothing but kind of like a class library only, like I created for my own. Okay. So it's a very simple process over here, but this is all available in your local machine, right? This is not going to run outside over here, right? If you want to do that, that is also available. I think there are pip packages available, or you can also just create a build over this. There are Maven and Gradle builds present, which is kind of, again, for web applications, right? To do that. But again, there are possible ways to do that, but we don't have specific popular packages managers name like that. Okay. No, Aditya. Template is what you are saying, right? In CPP, what we do is we just create a template. For example, if you have to run a while loop, over at the top, we define a set of templates and it just makes your, code very sharp and very easier, right? That is what you're talking about, templates in CPP. Competitive programmers use that a lot. No, in Java, we don't really do that. That's why Java is not actually preferred for competitive programming a lot as well. There are ways to do that, but those are not very optimized ways, which saves your effort a lot. Okay. All right. Yes, Paras, that is the case. We will come to that when we will do Spring Boot. Okay. So those concepts like Maven build, Gradle build, right? All these concepts, they will also come. Okay. Everyone is clear so far? Any questions? We will come to that. So when you create your code, right, Milind? So in Node.js, it's very simple, right? You just create your code, you just build it and it starts running, right? So in Java, you need Maven or Gradle to actually build your code. So you have an XML file. Just say in Node.js, we have package.json file, right? Which kind of have all the information about the code, and then it builds your code, right? Here in Java, we have concepts like Maven and Gradle, which are kind of used to build your code. It's like kind of stitching all of your code together, and then kind of, it's used for making a library out of it, everything. Yeah, kind of. Yes, Venkat, I can understand. But this theory is important. Trust me, from an interview sort of perspective, I have gone all of these questions, right? So it is kind of important to know all of these things. It'll just happen for 2-3 classes. Then we'll just rush up to a hands-on programming. Okay. Let me just do one last thing. Then we will actually do a very nice math question as well. Okay. Chalo. So the last thing is, what about JDK? Okay, there is another term also, which is JDK. Okay, so JDK is actually going to stand for, the last thing that we have over here is JDK. JDK basically stands over here for Java Development Kit. Okay, so it is a software development kit that is required to develop applications in Java. When I say applications, I said full-fledged applications, web applications, or any type of applications, right? Right. So when you download JDK, JRE is downloaded with it. Okay, so kind of understand it this way, that when you have JDK, you have JRE plus compilers plus debuggers in it. So if you are using IntelliJ, what it will say is, for example, I have to do a new project. Okay. So whenever I try to make a new project, it actually asks me the JDK that you want to use, right? So here I am using Oracle 19 JDK over here. So if you don't have that JDK already present, you can download it as well. By default, the JDK is installed in this. Okay. So JDK has the JRE. JRE has the JVM. How I like to kind of, again, this is the trick method to learn. JDK, JRE, and JVM. J is common for all of them. D is actually coming first in alphabetical order, so it's like the highest level. Inside this, you have JRR after that, right? So it's exactly inside it, we have R, which is JDK inside JRE, and inside JRE, after that, become JVM. So JRE has JVM inside it. This is again just for me, how I like to kind of learn this way, right? To kind of never forget what is inside what, right? But again, understand that this is how you can also learn this as well. Okay. So JDK is actually a software development kit that is kind of like one entire kit, which is used to develop applications in Java. When you download JDK, JRE automatically consists or comes along with it. So to kind of give you the bigger picture now, this is your JDK. When you install JDK, JRE comes with it, right? JRE has JVM installed in it, plus class libraries. Like I said, some already built and tested libraries, which you can use. It's just like a package of JVM and class libraries, plus JRE, plus what you do is compiler is present in JDK. Debugger, which is again used to debug our application, is already present. I hope this makes sense now to understand all the relationships and how all of them are actually connected. Okay, so this is how kind of, the overall architecture works over here. Okay, so JDK is a software development environment which is used for making applets. Again, like I said, applets nothing but for sandboxing and for making Java applications. The full form of JDK is Java Development Kit. Java developers can use it on Windows, Mac OS, Solaris, and Linux. JDK helps them to code and then to run those Java programs. It is possible to install more than one JDK version on the same computer. More than one JDK version on the same computer. Okay. Why do we use JDK? Point number one, it is a tool. It has all the tools which will help you to write Java programs and JRE to execute them. It includes the compiler, the Java application launcher, the thing that actually launches your Java application. It has that. It has the compiler, which converts code written in Java into bytecode. Okay. The Java application launcher is actually the one that opens a JRE. It loads the necessary classes and executes the main method, which is like this method. So every Java code is going to have this main method, which is going to be the first point of entry for executing any Java program. We will come to that. Okay. Now, the next thing I'll repeat once again, which is about JRE. JRE is a piece of software that is designed to run other software. Okay. It contains class libraries, loader class, and the JVM. Loader class, we'll talk about that later. Okay. In simple terms, if you have to run a Java program, you don't want to build applications using Java. For that, you would need a JDK. You just want to run a Java simple program, you need a JRE. If you are not a programmer, you don't need to install JDK if you don't want to kind of make applications, but you would need JRE to run your application. Why? Because first of all, JRE has the JVM, which is going to actually convert your bytecode. Secondly, it has the class libraries, which you actually use to put in your systems. I hope it helps you to now understand how all of them are stitched together. Clear to everyone? So the concept, Milind, is a little different. You won't be able to relate as such. Like if you are kind of thinking that, in Python, we have a Python package manager. In Node, we have a Node package manager. Similarly, something would like to that come in Java also. The concept is different. Okay. Because again, Java needs JDK, right? So it's very dependent on that. Even if you kind of make a small package out of it and upload it, right? Again, that package is not enough. That package is not compatible to run on everywhere. In Node.js, you have in JavaScript, you have Node.js, which is not machine dependent, right? It's a runtime environment in itself. But when it comes to Java, the concept is different. Okay. So with Python and Node JavaScript, you'll be able to draw the relation and work along the same parallel path. With Java, we kind of diverge paths a little bit. Okay. But nonetheless, we will kind of talk about, right? And we will kind of understand that as well, but understand, like, this is kind of a little different on how it works. Okay. Clear to everyone so far? Should I also shed some light, like Miran is saying, about the history of Java? Would you all like to know about that as well? I mean, I'm all about Java, so you can extract as much information from me as you can about Java. Okay, let's just take it for one last minute. Okay, then we'll not go too deep into it. Okay, because I am a Java fan, so I like to talk about Java as much as I can. Very simple history. We just convert it in a minute. Okay. First of all, Java, understand, was initially called OAK, Oak. Okay. Oak is a discontinued programming language which was created by James Gosling in the year 1989, initially by Sun Microsystems. Okay. It was nothing but a set-top box project. Okay. Originally, it was just used for developing or handling portable devices. Okay. But Oak was a massive, massive failure. Okay. In 1995, Sun Microsystem company changed the name from Oak to Java and modified the language to take advantage of the World Wide Web, WWW. Okay. Later, in 2009, Oracle corporations acquired Sun Microsystems and took ownership of three important, I would say, Sun Microsystems software assets. The first is Java. Do you know about the other two? So they acquired Sun Microsystems and they took ownership of three important assets of Sun Microsystems. First is Java. Other two, very popular. Okay, I'll give you. First is Java. Second is Solaris. Third, very, very popular. Yeah, you use Oracle all of the world. MySQL. Right? MySQL, it got no. You heard about Oracle MySQL all the time. So when it acquired Sun Microsystems, it got ownership of three very important aspects: Java, MySQL, and Solaris. Spark is a different. Okay. So when we had, I would say, Java. So initially we had JDK 1.0. Before that, we also have JDK Alpha and Beta. Don't have to go about that. Okay. After that, they make JDK 1.1. Okay. I think it got in 1997, right? Then you have a few of J2SE, Java 2 software environment kind of a versions, 1.2, 1.4, right? Then they have Java software environment, let's say 6, then 7 came, then 8 came, then 9 came in 2017, then 10 came, then so far, 15 is what came in 2020. And if you will see over here, like it kind of changes, right? So feel free to use any latest, I think so far by 2020 were Java SE60. Okay. Right. That is what the entire, I would say, history of Java as a language. Yes. Solaris is actually a proprietary Unix operating system. Okay. It's a proprietary. It was, I think it is basically for proprietary uses. So basically, Oracle Solaris is now what it's called. It is used to develop VDCF. Do you know about VDCF? That is where Solaris is most used. VDCF stands for Virtual Data Center Cloud Framework. Those are kind of management softwares. Solaris mostly find its applications over there. So it's not for basically a lot popular for consumer. Clear to everyone? Everyone is absolutely clear? Any questions, any doubt? I would say, again, Milind, to answer your question, it's not really a lot for consumer end use. Oracle Solaris is actually used for an enterprise operating system for Oracle databases and Java applications, which Oracle Inside creates. Okay. So it kind of is very enhancedly focused on CPU, memory, file system enhancements. Perfect. So should we now, okay, I wanted to show like a quick demo of CISO statements and everything related to that as well. Okay, but kind of we can do this later in the next class as well. Let's actually do a good maths puzzle. Okay, I like to kind of do these at the end of the classes, right? So we kind of had a little good cool down also while actually, ending the session. Does that work? So I think someone asked the question. Milan says Oracle mostly earns by all of this kind of like less. So they have, although they have like quite a few things which they kind of generates revenue. So Oracle SQL is paid. Oracle SQL is not free, right? You have to pay a subscription amount to be able to get access to Oracle SQLs and everything like that. MySQL is free. Okay, so kind of using these, I would say Oracle kind of makes extensive money using these range of products and services to enterprises. Okay, they are not really, they're kind of in a B2B kind of a product. They're not in a B2C, in a lot of B2C kind of architecture. Okay. Yes, now they've started. Okay, now what we'll do is, to end the session nicely, we are going to do a math problem. Again, this can be very easily converted into a coding problem as well. So it's always good to know these. For example, okay, I give you three numbers, any three numbers, A, B, C, right? What you have to do is you have to give me the sum of pairs, sum of the product of the pairs of all the numbers. For example, if I give you A, B, and C, what you have to tell me is the output of AB, AC plus BC. These are the only pairs I can form with ABC, right? If I have three numbers, ABC, the pairs are always 3C2, right? These are all the pairs I can form. Similarly, if I have A, B, C, D, right? So you have to basically give the sum of this, right? If I have A, B, C, D, right? In this case, you will have to tell me AB plus AC plus AD plus BC plus BD plus CD. Okay, so you have to tell me the answer over here. For example, if I give you the numbers 2, 3, and 4, and if you apply the same logic over here, the answer will be 26. Clear to everyone? As you can see as well, 2 into 3 plus 3 into 4 plus 2 into 4 is 26. Now you think how you will actually solve this question. Are you going to kind of do it from scratch? Do not put your answers in the common chat. Please put your answers in the private chat only, so that I can know actually it's working. And I want the proof. of how it is working. So you have to give me the proof as well. Nobody will answer in the, I would say, common chat. Everyone has to kind of answer in the private chat so as to really know what's happening and how does these all concepts work. Take 2 minutes, okay? Pause here, take 2 minutes, think how it would actually work, and then we will discuss. I'm seeing some answers. Paras, you are in the right direction. Also, kind of give me the proof. How does it would work? Like, obviously, I hope everyone knows that if I give you 20 numbers, you won't just go ahead and start multiplying all of them. You know? That is not optimized, right? If you are saying to the interviewer, I will run a loop, take this number, multiply with this and this, take number, multiply with this and this, trust me, you're almost rejected, right? We need something brainy over here. We need something optimized over here in order to be able to do that. So simple answer, Vinayak, no, JVM does not have a operating system on its own. Okay, it is running inside an operating system. So it's kind of using their resources. Very good, Paras. Yes. I think Vinayak also got the answers. Very good. This is how, like, this is the correct answer that you gave for interview as well, right? This is the thing that will ask you for interviews. I'll give a hint. It would need your basic maths to be in play. Vinayak answer is correct. Paras answer is also correct over here. Very good. So you knew this question, I think. This is a popular FizzBuzz round question. Do you know what FizzBuzz rounds are? For companies? So let's say there's a company who has to hire 10 people. Okay. So, or let's say 20 people, and there are 500 applicants. They can't just do interviews for all of them, right? So they do a FizzBuzz round. They give a basic programming problem, 2 basic programming problems to all those 500 students. And those are not difficult problems. These are usually easy problems. And based on that, they automatically reject approximately 70% of the audience for interviews. So imagine if 500 people are applying on the FizzBuzz round only, usually 70% of the people get rejected. And it makes sense also because if you can't solve an easy coding problem, it doesn't make sense for you to kind of proceed for interviews. So that's why they kind of ask you these FizzBuzz kind of a problem. FizzBuzz is a particular type of problem also, but problems similar on that level are also kind of known as FizzBuzz problems. Anybody knows how to do this? Or do you need another minute? Again, run it. The solution is not bad, or I would say the solution is correct, but the solution is not optimized. That's what I can say. Hint is a basic maths formula that you probably did in your school. Like it's not something that it would require your college knowledge also. Okay, let me help you out. You can do that, but Vimal, that is just kind of over here. Like even if you calculate NCR, there is no direct way to do that, right? You'll have to apply the formula for NCR as well. So again, like if you're, my idea being, if you're leading into that direction, it will not help you over there. Okay, chalo. Let me help you out. Do you all know the formula for A plus B whole square? To us discuss the answer, do you all know about the formula of A plus B whole square? It is what? A square plus B square plus 2AB, right? Okay. What about A plus B plus C plus whole square? Same idea, right? A square plus B square plus C square plus 2AB plus 2AC plus 2BC. You see where I'm going with this? You see where am I going with this? Can I not just do this? A plus B plus whole square divide minus A square minus B square minus C square, which is equal to what? 2AB plus 2AC plus 2BC, which is nothing. If I take 2 common, this is nothing but 2AB plus 2BC plus this. Isn't this what we were looking for? And now, isn't this can be just simply calculated in a complexity of O of 1 without having to do all those multiplications? In a single operation, we will have our answer. Clear to everyone? So if now the same things come for, let's say, 4 elements or 5 elements, okay, this is what the simple formula will change. Clear to everyone? This is what we do at AlgoCamp. We want to not just upscale you in terms of teaching, okay, you know, this is JDK, this is JRE, JVM, start writing code and let's go to just SISO code and let's just talk about arrays, strings and all. For those of you who have done already courses with us and been with courses for Sanket's backend courses and, you know, what we have been doing in the past, you would know this is how we do the courses, or this is how we like to learn so that we understand over here. Clear to everyone? We want to not just upskill ourselves to just have code in our hands. We also want to upskill ourselves to know that, you know, okay, this is how the logic works. We just upscale our, because math, trust me or not, is a very, very crucial form of how programming works, okay? Later, when we will move to time and space complexity concepts, recursion, function calls, right? And we will solve math, GCD problems, exponentiation, right? All of them will actually be required. So make sure you are comfortable with basic equations, mathematical formulas and equations. Make sure you also know about logarithmic concepts and you're comfortable with that, okay? That much is enough. You don't have to learn sine theta, cos theta and everything. Basic number theory, logarithmic concepts, equations, everything is that enough. Polynomial, binomial. Good. Clear to everyone? Dinesh says to explore one more time. Dinesh, what we are simply doing is, we are simply saying that you have to find this out, which is AB plus AC plus BC if the input is ABCD. If the input is ABCD, 4 numbers, the output should be this. So you have to find out the sum of the product of pairs of all numbers. So that is AB, AC, AD. If this is given, this is what you have to find out. Find all the pairs, make all the pairs, add all those pairs product and just give the final output. So what I said was, in order to able to get this, or for example, in order to get the output for this is what you have to do. So know the simple formula that A plus B square is what? A square plus B square plus 2AB. Cut to A plus B plus C whole square, because you have been given 3 numbers. The formula for that is A square, B square, C square plus 2AB plus 2BC plus 2AC. You see, this is nothing what you do in school is nothing but having actually the product of all of these numbers. After this, in this kind of a formula is what actually you have the pair of all the numbers. If you will scale this formula to this, no, it is actually this is what it is. Okay, so again, the idea being that if you simply just do this, take all of these terms, take it on the left hand side, do this, this is what you're left with, and just took common 2 out of it and this. So if anyway, now someone gives you the input A, B, C, what you will do is simply apply this particular part over here. For example, if it is now in real world, let's say the elements are 2, 3, 4. What I will simply do is I will do 2 plus 3 plus 4 whole square minus 2 square minus 3 square minus 4 square divided by 2. And this will give me nothing but 2 into 3, 3 into 4 plus 2 into, and you can verify that as well. Okay, this is nothing but 9 square. Let me do one step, minus 4 minus 9 minus 16 by 2. This is 81 minus 25, 29, and you can like move forward like this. Yes, at one point of time, it's just how your brain works. Clear? Dinesh? Dinesh asked, right? Are you clear on how exactly you're supposed to be doing this? Awesome. So what we'll do is, I'll just share you how we are actually going to work through the concept. Just give me a second. Or like how we are going to work through the notes. What I like to do is this way only. Feel free to let me know what you're more comfortable with, and then we can work around that. So what I will do is at the end of every class, so far we've not written code, so it doesn't like really make sense to do everything on that sort. But whatever I wrote in the class now, it actually makes a very beautiful PDF file out of it. I'll just create, I'll show it to you how it looks like. Okay, so this is how it will look like. This will be a PDF file which is zoomable. So you go here and whatever we have written today, all of it will be available like this. Okay, so these are good notes. You don't have to kind of invest a lot of time writing all of these. That is why I was saying in my classes, just sit back, relax and listen. Everything will come as like a, जिसे कहते हैं, chef case kind of notes for all of you. So just invest your time in learning. Okay. Clear to everyone? I hope these kind of notes would help all of you. Harshdeep, you don't have to derive any formula, right? I think it's pretty clear what you have to do. Matlab, try to generalize it. If you have, let's say 6 elements also, so what will you do? A square plus B square plus C square plus D, sorry. It doesn't matter, right? You know the trick over here. This is for 5 elements. If it's for 6 elements, you kind of go forward like that. Okay. Vimal, don't worry about that. How to actually become prepared for interviews and not just do and ramp up lead code problems is what this course will help you understand. Okay. These are very fundamental problems. So I'm not going too deep today in the very first class itself because it'll scare you off a little bit, right? But don't worry. We are all about not just like, understanding concepts, but to become a better problem solver. Okay. For every question later, we will learn about intuition building. In my classes, for example, even if you're solving a simple array question, we'll talk about intuition building. We'll talk about how to draw observations from the questions. Then we'll write the algorithm for that question, sometimes pseudocode also. Then in the entire implementation of the question, followed by time and space complexity. Okay. So I usually touch upon all these 5-6 concepts for every question. Okay. Yes, Dinesh, I'll try to add more probably at the end of as many classes as I can. Okay. because it just trains your brain. Perfect. So should we wrap up today's session over here? Thank you so much for attending for today's session. I hope you had a fun time and you were able to understand everything. How is there any feedback, anything that you would like to say, anything that you would like to kind of take care of in the next sessions? I'm all for feedback and want to know, how exactly was your experience? Did you were able to understand everything? Should we change our approach a little bit? Or my, teaching style, could we do anything different? Everyone is happy, right? Because I want a 515 score. And if there's anything else that needs to be changed, I will be more than happy to work on that. 2 hours, generally, we would like to have the classes. 2 hours classes generally. Tuesday, Thursday, I'm thinking let's do 9 to 11 only. Saturday classes, if you would like to have the weekend to yourself, we can do sometimes 12 to 2 also. Okay. Like weekend classes, we can do 12 to 2 just to let you guys free a little early. Okay. Sorry, I think I got dropped off somehow. Everyone is okay, right? I didn't hear from a lot of you in the chat. Anya, Anmol, Ayushman, Harish, and I think recording would be available approximately like 5 hours max, should not take more than that. Actually, you're still kind of figuring out a few things about the platform. So it will be 2 or 3 days to get comfortable because it's a new platform entirely. But I think it should not take longer than that. Okay. When we will integrate in the platform itself, then don't even expect it to take longer than 2 hours also. Where can we see this PDF file? I'm thinking to create a drive. Okay, usme I'll create, I'll keep uploading everything, but I'm also a little bit inclined towards GitHub also, because then you will get comfortable with GitHub commands, basic commands and everything. So let me figure that out a little bit. Give me a day or so. I'll kind of become comfortable with that and I'll let you. Okay. Anything else? Tushyap, Braj, Sayantika, everything is clear? Rohit, Puneet also, I didn't hear a lot in the session. Awesome. Let's end the session. Thank you so much for attending today's session. I hope you had fun and you had a good time understanding. Okay. B, when you'll explain difficult topics, please try to explain them in English because it helps in submit. Difficult topics, again, you already have the curriculum for the course. It will come time and again, right? We'll try to deliver as much as we can. English, I am not sure because there might be some people who are just completely comfortable with English. Okay. So I cannot assure on that. But again, these things will get comfortable more when we've done 5-6 sessions. Okay. In the next sessions, we'll keep a 5 minutes break in between also. Okay, today it was the first session. I wanted to kind of convey a lot, so I didn't keep it. But we'll keep those breaks also, 5-10 minutes in break. Okay. Chalo then, all set for today's session. Thank you. Have a great week. We'll all meet on Thursday now, 9 p.m. The first 2 weeks of classes are all live. So assume that there will be no recorded lectures for the first 7-8 classes because these are fundamental classes. I want to myself teach them live in the session. Okay. Perfect then. Thank you guys. Bye. Good night.